fundamental. Now in this we will discuss regarding the fundamentals of light along with its properties of the wave nature as well as particle nature. Okay, so as I had told in the second video, we will basically focus on, let me just zoom it, the wave and particle nature of the light. Okay, next we will see the optical communication network features, like the key advantage that we have along with the fiber properties in the modern network, and what are the different network types, and last we will recap whatever we have learned. Okay, now let's come directly to the point, that is the wave nature and particle nature. Now light behaves both as a wave and as a particle, or nothing but as a stream of photons. In the wave nature, or in the wave perspective, we can see that light consists of electric field and magnetic field. So in case of the wave nature of light, that initially also we were describing it, when the light propagates, it has a electrical component as well as magnetic component. But when we define this in case of particle nature, they are basically defined as nothing but the photon concept. So light behaves as particles or photons. So when light is hit, okay, or the energy that light carries, the energy in a discrete packet of light energy, and that we defined as a photons. Now the follow here basically these are basically understood very clearly using this photoelectric effect, that explains how the light is detected by the converting photons into electrical signals. Okay, so when the incoming photons are, like when they are interacting with a metal surface, now they, let's say these are the, this is the metal surface, and when the light energy hits, so electrons, okay, now these are electrons that is emitted out. So these are basically explaining you the photoelectric effect, and here we see the particle nature of light. In the wave nature of light, these are basically explained when light is propagating inside the fiber core, using the properties such as like interference, diffraction. Now let me add some more points when we discuss regarding the wave nature as well as particle nature. So in case of wave nature of light, so when light is an electromagnetic wave, these, as I explained you, it consists of electric field as well as the magnetic field. Okay, so this model is essential for understanding how light propagates inside a fiber core. Now these will get reflected back, okay, when they are traveling inside using the total internal reflection inside the core medium through the TIR effect. And these experiences the impairments such as like chromatic dispersion, okay, or we have modal dispersion. So these we will cover in the later part. In case of particle nature of light, in this what happens, they are nothing but, as I explained you before, they can be treated as nothing but a discrete packet of photons. Okay, now these photons are generated when these electrons in atoms, okay, so earlier when I was telling you, these electrons are ejected out when metal surface is hit by light. Okay, and they go from lower energy state to higher energy state. Okay, so they go from, they have the ground state, and they go from ground state to excited state. So these electrons, so in from ground state to higher excited state. When they come back from the higher energy state to lower energy state, they emit these photons with that energy, and that is your signals. Okay, so this is basically explained using the photoelectric effect. And certain materials, they emit these electrons, and they, when they are exposed to light. Now come back to the duality matter that we understand. So we cannot, like, just explain that it has only wave model or it has only particle model. Now some of the property of light is explained using the wave model, and some of them are explained using particle model. Okay, now I have given example here that wave model explains the propagation, chromatic dispersion, as well as polarization inside the fiber. And this particle nature explains how the photodetectors basically works. Okay, or photodiodes convert the light signals into electrical signal. Now coming back in the optical communication network features, okay, we use the property of these lights for propagating high amount of data. Okay, so whenever the requirement of high bandwidth is there, we go for this light propagation via fiber. Then it also has the low latency, high reliability, and longer reach. Okay, compared to the copper cables that we were using initially. And also the scalability. Let's say when I talk about scalability, it's basically how, using the advanced DWDM or the dense wavelength division multiplexing or modulation types, we don't have to add more physical mediums. Okay, using the same fiber, multiple channels are created inside fiber, and we can use those multiple channels to carry more of this bandwidth. Okay, more bandwidth can be transmitted. So these are also like mostly used because they are not affected by this electromagnetic interference, unlike the copper cables. And it can also survive the harsh environment. Okay, like high temperature, or obviously the electromagnetic interference are not impacting such network. Okay, now our network types are divided into three major categories. One we have as a metro, then we have long haul, and submarine. These are mainly divided based on the distances that it covers. Okay, so for the shorter distances up from let's say 20 to 100 kilometers, we call that as a metro type. Okay, then we have up to 3000 kilometers, these are long hauls. Then we have submarine, which is over 5000 kilometers. Okay, these are basically connecting the, like, different countries under sea for like ultra long, like, data transfer. Like if you consider such examples, they can be like a network of, let's say, Google. So they have their own network that is running undersea. Similarly, we have the Meta Enterprise, or such network which is very global and they require so much capacity to handle. They will have a submarine kind of network. Now all of these requires obviously the amplification or the dispersion management. Okay, now common applications are also like given here, like interconnection of different islands or international connectivity or intercontinental connectivity. They can go for long haul or submarines. Okay, for shorter distances like data center interconnect, they go for metro kind of network. Now a little bit more detail of this network detail. Like metro also supports this cloud providers or ISPs. Now long haul will be balancing the spectral efficiency with signal integrity. Submarine is for obviously when you are laying cable undersea, it has to last long. Okay. So apart from long reach, they also go for higher lifespan. Okay. And obviously it should not get impacted with high pressure or so high tensile strength steel cables, steel casing fibers are used. Now let me just brief regarding the key takeaways that we had. Okay. So in optical communications, we first learned how we convert the electrical signal into modulated light and send them to the fiber. Then we also learned regarding how this electromagnetic spectrum, we use a specific wavelength and frequency range. Then we have the five properties that we understood of light, that is wavelength, frequency, amplitude, phase, and polarization. Then we have the six ITUT bands that is defined, that is O band, E band, S, C, L, U, and they are basically used to optimize the performance, and they are inversely proportional, that lambda is equal to C by frequency. Then we use the meter, okay, the decibel meter, which is a logarithmic unit for the optical parameter, like you measure loss or gain or power. Then we have the light behavior. It can behave both as a wave or particle nature. And then we also discussed regarding the optical communication network, which offers high bandwidth, low latency, and high scalability. Then we defined our network into three different parts, that is metro, long haul, and submarine. And they are basically based on different distances and different roles. Now in the upcoming video